Hi guys, welcome to Science with Kanash. Today we'll be doing atoms, elements and compounds part 2. So this is the syllabus content. First we have the ions and the ionic bond. So the formation of ions. Now the ions are formed by the loss or gain of an electron. When an atom loses an electron or it gains an electron, it becomes an ion. The uh, Basically we lose the atoms lose or gain electrons to get a noble gas configuration, that is they want the full outer shell of electrons, and this is because it helps in stability. So we have two types of ions. One we have is the negative ions, which are anions, and they are formed by the gain of electrons. So when the atom gains electrons, the number of electrons becomes greater than the number of protons, and that's why it gains an overall negative charge. So that's a negative ion. And we have positive ions, which are cations. Cations are formed by the loss of electrons. So when the atoms lose electrons, the number of protons are greater than the number of electrons, and thus it has a overall positive charge. So cations are the metal ions and the anions are the non-metal ions. Here we have the sodium atom. So the sodium atom in the outermost shell has one electron. So when it loses this one electron, it will have the full outer shell of electrons. As you can see in the next diagram, it has full with a +1 charge. So it's a cation, sodium cation. And here we have the chlorine. Chlorine has 7 electrons in its outermost shell, so it gains one of the electron and it becomes an anion with a negative charge. So formation of ionic bonds. So ionic bonds are formed by the it's like a metal plus non-metal, and in ionic bonds they have electrostatic force of attraction, which is the ionic bond. It's between the two opposite charges. Like here we have sodium chloride. So sodium is a positive ion and chlorine is a negative ion. So both of these have electrostatic attraction between them, which is why they form a bond. Then we have dot and cross diagrams. So dot and cross diagrams are that show the arrangement of the outer shell electrons in an ionic or covalent compound or element. The electrons are shown as dots and crosses. In the dot and cross diagram, only the outer electrons are shown. The charge of the ion is spread evenly, which is shown by using the brackets. So that's why we have the brackets. And then we write the charge on each ion is written at the top of the top right corner. So here we can look at the bonding of NaCl. I have drawn all the shells to show the explanation, but in dot and cross diagrams we usually just show the outermost shell. So sodium the cation and chlorine anion. Sodium has this electron which it loses, and the same electron is gained by chlorine. As you can see in this one, chloride ion, one is a cross. In all the dots there is a single cross, and that cross is the electron of the sodium ion. Then we have the lattice structure of the ionic compound. So lattice structure is basically the regular arrangement of alternating positive and negative ions, and this part of is only for the extended students. So as you can see in the cube, there is a red dot which represents the Na plus, and then the green which represents the Cl minus. So they are in a regular arrangement and they have an alternate positive and negative ions are there. So ionic compounds have overall no charge, and group 1 and group 7 is for the core students, and the rest of the groups ionic bonding is for the extended students. So here I have the example of magnesium oxide. So magnesium is in group 2, and magnesium has two electrons in its outermost shell, the magnesium atom. And when magnesium atom loses those two electrons and oxygen gains those two electrons, so oxygen has a -2 charge, and then they form magnesium oxide. So properties of ionic compounds. Ionic compounds are solid at room temperature. They have high melting point and boiling point. They are good conductors of electricity in molten state or in solution. and they are poor conductors in solid state. Now, the reasoning for all of these points is not for the core students, it's only for the extended students. So, it has high melting and boiling point because of the giant structure, and as we read that it has strong electrostatic force of attraction. So that's the reason that the melting point and boiling point is high, as high amount of heat energy is needed to break those bonds. And they are poor conductor in solid state because ions are the ones which carry the charge. So since ions in solid state will be in fixed position, they won't be able to move and carry charge. Whereas when they are in molten state or in solution, the ions are able to move and they can carry a charge, and that's why they are conductors in molten or in aqueous solution. Now let's move on to the next thing. We have the simple molecules and the covalent bonds. So covalent bond is formed by sharing of a pair of electrons, and each pair of electron represents a single covalent bond. So covalent bonding is only for non-metals, and it's also for the gaining of noble gas configuration. So for example, we have chlorine molecule over here. So they have the shared pair of electrons and each one is a covalent bond. And then we have the other examples which our syllabus requires to know. And in covalent bonding, it's important to show the overlap of the atoms. So the overlap, and then you draw the electrons within the overlap to show that it's being shared between the two atoms. Then we have some more examples like water, methane, ammonia, hydrogen chloride. These are all examples of covalent bonds, covalent compounds. So this is for extended students, and those all compounds we previously looked were like single bonds. Here we have triple bond. Nitrogen has triple bond, so basically it shares three pairs of electrons. And ethene has carbon carbon double bond, so the sharing of electron between a carbon and carbon is four electrons, that is two pairs of electrons, and with each hydrogen it's a single pair of electron. And for methanol, we don't have any double or triple bond, it's all single bond compound, but it is only for extended students to know the diagram. Then we have carbon dioxide. I'm sorry. So carbon dioxide, the carbon in carbon dioxide is bonded with two oxygen, and both of them have double bond. That means two pairs of electrons are shared. Properties of the simple molecular compounds. So covalent compounds are also called simple molecular compounds. They have low melting point and boiling point. They are usually gases or liquids at room temperature. Now, low melting point and boiling point is because of the weak intermolecular force. The covalent bond itself is a strong bond. It's an intramolecular bond, but the intermolecular forces, which is between a carbon dioxide molecule and a carbon dioxide molecule, is weak. So that's the reason it has low melting point and boiling point. And they are poor conductors because they have no free electrons or ions to carry the charge. Then we have the giant covalent structures. So we had a look at the simple molecules, right? We have giant structures as well. The three examples which we learned, two are for core and extended both, and one is just for extended. So graphite and diamond, and we have silicon oxide. So the structure of graphite is that each carbon atom is bonded to three other atoms and they form layers of hexagons, and each layer leaves one electron. Each carbon atom leaves one electron, so that electron becomes delocalized. And that's the reason that graphite conducts electricity, because it has delocalized electrons which can carry the charge. Then we have diamond and graphite are allotropes of carbon which have giant covalent structure. So allotropes are basically compounds which have different atomic or molecular arrangement of same element. So both diamond and graphite are made up of carbon, but the arrangement in diamond and graphite of carbon is different, and hence they are different compounds. They are allotropes. So both these substances, they only contain carbon atoms, but due to the differences in the bonding arrangements, they have different physical properties. And the giant covalent structures contain billions of non-metal atoms, each joined to adjacent atoms by covalent bonds, forming a giant lattice structure. So then in diamond we have that each carbon atom bonds with four other carbon atoms, forming a tetrahedron. All the covalent bonds in the diamond are identical and they are very strong, and there are no intermolecular forces. Now again, it's important to clear out that covalent bonds are intramolecular forces and there are no intermolecular forces in diamond, whereas in graphite the layers are attracted to each other by weak intermolecular forces, but in diamond there are no intermolecular forces. Then we have the properties and uses of graphite. So graphite conducts electricity, as I told you that there is one free electron left per carbon atom, so the delocalized electron basically exists in between the layers and they are free to move through the structure, and carry charge. And graphite has a high melting point, that is because of a giant covalent structure. So there are strong covalent bonds and they need a lot of energy to break. Graphite is slippery because graphite is arranged in layers, and although the atoms within the layers are joined by strong covalent bonds, the layers have only weak intermolecular forces between them. So, due to the weak intermolecular forces, the layers can slide over each other, and that's the reason graphite is slippery. And this property of graphite allows it to be used in pencils as an industrial lubricant, and as well as it is used for electrodes. Now, electrodes part cannot be explained right now, but when we have electrochemistry, and that it will be explained very well. But the reason it is used for electrodes is that it is non reactive. And then we have the properties and uses of diamond. So diamond does not conduct electricity as there are no ions or no electrons which can carry the charge. Diamond has a very high melting point as well because of the giant covalent structure and the strong covalent bonds. It is extremely hard and dense. Now it has strong covalent bonds, and each carbon atom is bonded to four other atoms. So basically there are a lot of covalent bonds and each covalent bond is very strong. Diamond's hardness makes it very useful in cutting tools like drills, and diamond has the following properties that these were the properties of diamond. And diamond is very expensive for jewelry purposes as well. And then we have to look at silicon oxide. Silicon oxide is only for extended students, as I previously told. Silicon oxide is not as expensive as diamond. That's because silicon oxide is naturally available, naturally as sand and quartz, that's our silicon oxide. It has a similar structure to diamond, like each oxygen atom forms bond with two silicon atom and each silicon atom forms bond with four oxygen atom. Now because of each silicon atom forming bonds with four oxygen atom, it gives a tetrahedron structure which is similar to diamond. So comparing diamond as and SiO2, so they both are hard, they both have high boiling point, they are insoluble in water and does not conduct electricity. Silicon oxide is cheaper, as I have told, and silicon oxide is used to make the sandpaper and to line the inside of the furnace. Then we have metallic bonding. So in metallic bonding, we have giant structures. Basically, it's electrostatic attraction between the positive ions because metals only form positive ions in a giant metallic lattice, and sea of delocalized electrons. So the outer electrons no longer belong to any specific metal atom, and that's why they are said to be delocalized. And this means that they can move freely between the positive metal ions and act like a sea of electrons, and that's why we use the term sea of electrons. And then we have the properties of metals. So metals have high melting and boiling point because of the strong electrostatic forces of attraction between the positive metal ions and the negative delocalized electrons within the metal lattice structure. So basically the attraction is between the positive ion and the electrons, and it is very strong, and that's why it needs a lot of energy to be broken down, and hence we have high melting and boiling point. Metals are good conductors of heat and electricity. This is because of the delocalized electrons, which can move and carry a charge throughout the structure. So they can carry electricity as well, they can conduct electricity. So most metals are malleable. Now, this means that they can be hammered into shape. This is because the atoms are arranged in layers which can slide over each when force is applied. So metals can, you can give any shape to metals, and most metals are ductile. That means they can be pulled into wires. This is also because the atoms are arranged in layers which can slide over each other. So as we have the copper wires, that means copper is ductile, that's why it can be pulled into wires. And many other metals we have seen in our house, they have different shapes, but it's the same metal. That's because of the malleability. So this is the end of the topic, atoms, elements and compounds. Next topic of chemistry is stoichiometry, which is quite full of numericals, but it won't be that tough. So see you guys soon. Thank you.